irritating.
Hello, Mr. Wan, right?
Yeah.
Last lesson we talked about the inner join, right? So the basic syntax for this inner join, SQL, structured query language, right? SQL we talk about a few lessons.
Yeah.
Is the language, is a scripting language. It's actually the English, right? This is very descriptive language which you use to interact with the database, with the tables. So we have two tables, employees and department, right? And we want to inner join. Look, the syntax is select something, right? Select something from the first table, join or inner join. If you don't specify the type of join is inner join, okay? Inner join another table.
Why inner join?
I explain. Join another table on something. So this is explicit join, explicit inner join, okay? So when we join two tables, here, this returns, inner join returns like Venn diagram, right? Returns the records from both, it returns match records from both tables. So the syntax, okay? Select something, select everything from the first table and comma, everything from the second table. If these two tables are A and B, okay? So we can say select A dot star, comma, B dot star. From A, first table, inner join B, okay? We want to join B because we explicitly saying that we want to join these two tables from A to B and then on A dot ID equals B dot ID. So ID field, this is the common column from both tables, right? So we need something to connect two tables. That's why the ID is for, right? For in this case, look, the employee and department. What's the common part of these two table structures? The department ID, right? Department ID, also known as foreign key to connect two tables. Okay, so this is explicit join, as I said, okay? Remember the syntax. Select A dot star, B dot star from A, inner join B on A dot ID equals B dot ID, okay? And we also have another type of old school join, which is implicit join. The syntax quite simple. Explicit, implicit, okay? Select A dot star, B dot star from A, comma B. We want to select everything from two tables where A dot ID equals B dot ID, okay? And then you can put, subsequent condition, right? And then you can put the order, something like that, order by call A dot ID, okay? So this is implicit join, is also the inner join, right?
Explicit.
This is implicit, this is explicit. Two. Explicit, implicit. There are two words. Explicit and implicit.
Why are you like?
Okay? Explicit. Look, inner join. We say inner join. We know, right? Your intention is clear. We want to join these two tables. But this one is actually inner join, but it's implicit. Look, how is that implicit? Because look, we want to select everything from the first table and the second table from two tables, right? You can select from two tables where condition, this is joining two tables. A dot ID equals B dot ID and something, order by line. Okay, so we're done with the inner join. Okay, so today we're moving to left join. Okay, can you guess what's left join? If I change the keyword inner join here, I can change it to left, right? I can also change to right, or I can change it to outer join, right? Or full join. And I also can change it to cross join. Right? We talked about different type of joins last lesson. We mentioned that we're not going into details yet. So if I change to left join, guess what will happen?
Start with the left.
Start with the, so coming back to this Venn diagram, right?
Left.
Right?
Join it from the left side.
Kind of, look, this one. We have a Venn diagram, right? This is A, this is B. The inner join is this part, okay? So what's left join?
The left.
Is that we have this left table, we return everything from the left table and the part which is part of the right table. Okay, so what does it mean? Remember this inner join, we return the match record from both tables, right? So for example, this David thing is not showing because 103 is missing from this table, right? Yeah, it's missing, it's not here,
It's on the left.
It's on the left. For inner join, it doesn't return this record. Why? Because this record is not present in the second table. Let's inner join. Okay, so let left join, simple. We return everything here, right? Even the David. But look, the department ID for David is missing, right? In the result table, what should we put for the David? This is David here, right? So what department name? Department name. This is department ID. The name, department ID, department name. So there's missing. This part is missing from second table. So we just put the keyword new. That's it. That's the left join. Okay. So let me repeat. The left join is that we return all the records from the first table, right? And also for those records which are matched in the second table. And for the fields missing, right? For example, for those records which present in the first table but not in the second table, we just fill it with the null. Okay, it means empty, it's not found. Okay, this is the left join.
Why are we learning about left join and join?
Then you raise a very good question. Why do we need to join the tables, right?
I didn't ask that.
Look, this is relational database. So we have a table stores the employee. We have another table stores with the department. So it's very concise. It's simple. It's not storing the duplicates. Okay. So look, what happens if I put these two tables together? So if I say I have a one giant table, okay, one big table stores everything. So look, employee ID, name, department ID, and then department name. Look at this. So Alex is from department ID 101.
Alice, not
And
Alex.
Charlie is also at 101, which is the HR. Okay, so let's say we have only one table, HR. So later, if I decide to change the ID to 105, let's say I want to change 101 to 105, then I have to modify two multiple records, right? Because 101 mapping to HR, 101 mapping to HR. If I put it in the same table, I have redundancy. Does it make sense? So that's why I split into two tables. So later, if I decided to change the 101 to 105, I can just change this bit, right? And then here, I don't have to modify the multiple records. And if I store everything into a single table, then also it will cause the inconsistency. What happens if you change 101 to 105 HR, but here it says 101 to HR? You haven't changed this bit, then it causes the inconsistency. Do you get it? Okay, so for database, when we're storing the data, we usually split, we have different ways to split the tables. I split into different tables. And then since we have data in different tables, then sometimes we want to retrieve the information from multiple data. Okay? Multiple data, then we need to join them, right? We need to join them. So SQL, the structured query language, allow you to query the data from multiple database, and that's why we have different type of join. The inner join, right? The inner join, just think about the Venn diagram. The inner join, just the intersection part. The left join, the left bit. The right join with the right bit. Okay? And we're going to talk about that next lesson. And also the outer join, which is everything. Yeah. Just the difference is that if you don't find the record for the left join, right join, outer join, we just fill it with the node. Okay, and the cross join, which is the Cartesian product. Remember the last lesson we talked about, A, B, C, and then 1, 2. Cartesian join, the full permutation. What's Cartesian join? The full permutation. A1, A2, B1, B2, C1, C2. Okay. So this, if there are n rows in the first table, m rows in the second table, the Cartesian join will return n times m because this is the full permutation, okay? And then today we also talk about the implicit inner join and explicit inner join, the difference, okay? So we prefer this because this one is the intention is clear. We want to join this two table using inner join. This one is more old school and implicit and not very nice, okay? That's it for today. Bye-bye. Bye.